Hello everybody, I'm Michael from Archimede Design. It's been a while since I've done a video, but today we're going to do an example in Fusion 360 of one, doing motion joints, but adding those motion joints to components that we brought in from another source, such as McMaster-Carr. So I do this a lot. People might bring in these components from other sources. But then they got to have some modification to make them so they can actually have motion components and joints put on them. So we're going to go through that example today. I'll show you kind of where we're headed here. So this is an example of a drawer system that I've been designing for a teardrop trailer, but it uses drawer slides. So I want to show you how you get things to move like this within a model. So that's what we'll be doing today, so stick around. Also, if you like this video, when we're done, please subscribe and like. That way we can make sure that this video gets more viewership and gets out to people so they can learn these skills as well. So let's get started. Okay, so I'm not going to actually model this whole thing in this example. We're just going to use parts of this. So part of this is going to be, we're going to bring in some components from this file. And then we're going to bring in a component from McMaster-Carr. So I'll show you how to do that. So we'll start there. So what we're going to do is just start a new file. And let's just save this as drawer slide example. All right, so first thing is I'm just going to bring in a couple of the components of that file, so we can just use those as a starting point. So if you need to insert some components from another file or another assembly or total assembly, you go to this insert derive, and in this case we are going to bring them from here. In order to bring those from here, we can select the whole thing, we can select subcomponents or even bodies. Depending on what you bring in is what detail it's going to bring in. I want to make sure we bring in everything that's necessary, drawings and all that stuff just in case, but all I want are the sides and this top drawer. So I'm going to pick these two right here, and then underneath that everything else is also included. So there you can see it just brought in those two items, and it is still, if you look over into the browser, it is still connected. That little arrow right there, that black arrow, means it's still connected to that file. So if I went back into that Fusion file and made changes, then I would get a prompt showing me that this is out of date, and I can update this file. For this, I don't want to worry about that, so I'm actually going to go up to the drawer slide, or these actual two components, and I'm going to break the link to them. So since they're brought in together, both of them have been broken. The other thing to keep in note is that depending on how it was made, things like that, like these two bodies here on the sides are together so they can move together. But there were joints in that file, but they're no longer part of this anymore. So those joints went away. So in order for us to kind of move forward, we're going to want to at least ground one of these. So what we're going to do is we're actually going to ground the sides. So you can get the ground by right-clicking on the sides component and just ground it. That way it can't move, though this one can still move. We're just going to leave it there for right now. So that's, pretty simple. Most have done this. You've inserted a component or a body from another file. Pretty straightforward. But where I really want to go to with this is bringing in a component from an outside source that has multiple bodies, and how do we convert that so it can be used with motion joints. So to do that, I want to bring in a specific drawer slide for this design from And you do that also by going under the insert here. And here you can see that you can insert fasteners, SVG, whatever, all these different things. But the two that are most common for going to outside sources are McMaster-Carr and Trace Parts. I use McMaster-Carr a lot. I kind of like how simple it is. I'm familiar with the catalog. You can, it's pretty easy to order parts, things like that. So, to do this, we're going to go into McMaster-Carr, and so in here you can search for whatever. Anybody that's familiar with their catalog and online kind of know how it works. But in particular, I want drawer slides. And so if we just did drawer slides, you can see there's several of them. And in particular, in this design, I think I use a lever type one. So I do have the number written down. So we're just going to search for it by its number. So this drawer slide we actually want, because I've inserted it before, is this 11435A25. So we're just going to pick this one right away. And here, there's several different types that we can go into, 2D and 3D. So depending on what you're working on, you can bring that in. Obviously, many people work in SolidWorks, so you can bring a SolidWorks file directly in. But I'm going to go with the step file, pretty standard. And basically just going to download it. And here it's come in. I am going to rotate it 90 degrees and click OK. And I'm going to capture that position. I don't want it to necessarily move. So here we have our drawer slide. And if I grab this, it's just going to move. I can't, all these components, this one is one component that's come in. And if you see, it's just several bodies. So that's where we're starting from. And we want to end up changing this so there's components so we can actually do jointing with it. So the first thing, let's just check out what we got. We have this one, which looks like it's that middle slider. So let's just call it mid slider. This next one looks like it's the back slider. And here it looks like we have a stop. Oops. Looks like it's the stop on the back of that slider. And these others appear to be the bearings. And then we have the front. So the one thing with these bearings, we don't need to actually have them be separate components because they're kind of just sitting still where they're at. We're not actually going to show the bearings rolling. I'm pretty sure that those bodies aren't even constructed correctly necessarily to do anything with. So we just want to find these bearings, and we're going to end up just pairing them with the appropriate slider. Call it bearing 1 through 4. Okay, so I have those bearings, and if we kind of click on these, it looks like 1 and 3 would go together, and 2 and 4 would go together. So first thing, let's just take these bodies that we renamed and let's make components out of them. So we're going to create a component here, create a component here. The stop can actually go with the back slider, so we'll just wait on that one. And we'll create a component here. So we have components for back, middle, and front sliders. The stop, bearing 1, and bearing 3 can all just be dragged into the back slider. And you'll see that they are now bodies within all that. We have the back slider body, the stop, and the 2 bearings. Bearing 2 and 4 we can put as part of the front slider. Now, still moving all together, but the reason why that is it depends on where you grab it and how it's going to move, but they are independent pieces now that I can grab. And then now we can do some jointing to them. Just so we can see what's going on, and we're going to do this temporarily. We're still not going to place this drawer slide onto the frame of this box. But what I'm going to do temporarily is that back slider, we're going to ground that. And what we want to ground that so that one does not move. That way we can review what's going on with our motion and not worry about that one kind of moving out of the way. So everybody knows these drawer slides. The mid-track will slide up to a certain distance within that back one, and then the front one will move within the middle one, a certain prescribed distance. So that's how those things work. They nest inside of each other. So what we need to do is create joints of motion within those. And that motion is a linear motion. So we'll take a look at the geometry and kind of think how that might work. As we know, they roll on these bearings on features of the track. So here you can see on the middle slider, there's this plane that those bearings roll against. And then on the back slider, there's also a plane that those bearings roll on. And it's the same thing with the front slider and the middle slider. So those surfaces are going to be important for us defining the joint, the linear joint. So to do that, let's first work on the middle one and the back one. So you're going to go up to your joint icon here and click on joint. And before we actually pick our surfaces, we want to go to the motion tab here. And under the motion tab, you have choices of rigid, revolve, slider, cylindrical, pin, planar, and ball. And rigid is what allows you to move things, fix things obviously in just one position, X, Y, and Z. Revolve allows you to rotate things around a specific origin or axis. Slider allows you to move things along along a certain path with a prescribed distance. Cylindrical, on the other hand, kind of does both, rotating and sliding. You could use the cylindrical on this, but it would make more sense just to do a slider on this one. Pin slot, that's a pin moving within a hole and moving and rotating in certain directions. Planar is just a planar surface, and ball is 360 degrees. So let's go with slider and then go back to the position tab. So from this, what we're going to do is we're going to pick this surface right here. And when we pick this surface, you'll see that it kind of identified the center mark of the curvature of that surface. There's one on the end, one in the middle, and one on the other end. We're going to pick the one right in the middle. And it could depend on which one you want to pick. So, I actually could pick the one on the end and line those up as well, but we'll pick the one in the middle for this. And now we need to select our other component. And our other component is that surface on the back one right there. If you can see that. If we pick that, it's going to do the same thing. It's going to give me, it could give me a choice, depending on how I picked it. It could give me a choice of kind of hard to get in there. It could give me a choice of different alignment marks from center and back. I did pick back here. Okay, so we're picked the center to center. So now you'll see that it slid that into position and it lined up these two things center to center. And let's just hit OK for now. And I am going to also turn off these two so we can see this a little clearer. So what that's done is it has allowed me to do this. It's fixed it along that linear path, and I can infinitely move it forward or backwards. And we all know that that's why this stop is there, is to stop it from moving. And so, if we actually drove that in a little bit, you'll see it would stop right about there. So we want to make sure that that happens. So to do that, we actually can go back into that joint, and that joint is sitting right here. We can edit that slider joint and go back to motion. And now we have this ability to put in minimum, maximum, and rest offsets or limits. And to turn a limit on, you got to checkbox it. We're going to leave rest as 0. We don't want rest to be calculated or changed. Just leave it as 0 for now. And now if we want to do our minimum, so we want to back it off by a little bit. So I don't know, 0.1 seems fine. We'll do 0.1. And the maximum, so we know that when we brought this in, it's an 18-inch drawer slide. So that middle slide is actually maximum is probably 9 inches. So now you can see that I can't drag it backwards, and I can only drag it so far forwards. And as you change it, you can actually see up here, it shows 0.1. And then if I go drag it out, you can see it says 9. You can see that number there. And then the default is just having it be, it's closed. All right, so that one is done. So now we want to focus on this middle slider, or this front slider. So I'm going to do it again. It's the same exact setup. Motion, want to make sure it's slider. The position we're going to pick is, again, the trough surface that's here and that middle selection. And then we're going to pick the same surface that ball bearing would roll on in the middle. And it scoots it back as well. And the same thing's going to happen. That stop is also trying to stop this. So we're going to do the same things. We're going to go to the motion. We're going to turn on our minimum and maximum limits. The minimum is going to be 0.10. Actually, might be a little bit longer. Looking at where that stop is, it's actually going to hit this back edge back here. So we're probably going to want to move that a little bit more. And again, as a maximum, probably 9 inches, because 9 and 9, 18, obviously, right? So when you're in here, while you're setting this up and you think you have your limits right, you can actually click on this little play button and you can animate that joint to make sure it's moving within its limits. Nice little tool just to double check that you have the motion that you are expecting. Now that I have that done, if I grab this, you'll see that the first one is going to move until it reaches its limit. And now it's engaging that other joint, and it's going to move to its limit. So now we have full motion all the way back, all the way forward. All right, so now we need to put all this together. And so let's bring back top drawer and sides. And I'm going to need 2 of these, so I might as well create a copy of this. So I'm going to do a move and copy. Create a copy. Move and copy. And now in this instance, when we moved and copied it, the joints came with it. Other than this is not grounded anymore, so I can move it. But that's okay. The joints came with, and I should be able to slide them out. The next thing I'm going to do is I grounded this actual component, that back slider, and I'm going to unground it because I want to be able to move it as well. Okay, so the next thing is we need to move it in position. I'm going to do this really simply, just to make things a little easier. Normally you might, like this thing's been all measured up and everything already, but I need to now do a rigid joint of this back slider to the side and the front slider to the drawer, and I need to do that to both of them. So what I'm going to do is I'm just going to simply put holes all the way through this whole this drawer design stuff, just to make things a little bit easier. So we'll just create a drawing here, and we will just put a hole, let's say here. Dimension it. Let's do just 0.11. .0. All right, we have this hole in position. So let's finish the sketch, and I'm going to do all. Let's sort of flip it, and we're just going to cut through all for now. Technically, we can make it so it doesn't cut through the drawer, so we'll do that. Now let's remove the drawer for now. And let's put these in place. So now I'm going to just do a rigid joint. And we're going to do by going to the center of that. This one has to go over here. Flip it around, and then this other one goes here. Okay, so those are in position on the sides, and again, so now you can grab these and move them. Remember, the sides are rigid, so they're in place. So you can see we can move these independently just fine. Now what we need to do is attach it to the drawer and get the drawers to get it so when you move the drawer out the face of the drawer, everything moves together. I'm going to turn the sides off again just so it's a little easier to see. We'll put the top drawer back on, and for the time being, we're going to hide the mid slider, the back sliders. And what we'll do now is we're simply just going to do a drawing here, and we're going to project. I'm going to project. Let's project this one right there. Let's just hide the rest of the sliders. Hide the front. Okay. And we're going to do the same thing. We're just going to extrude that through all. Let's flip it. Cut. Flip it. Cut it. Okay. All right, let's turn the front sliders back on. And so right now, I can just move that. So what we're going to do is we're going to do again a rigid joint, rigid. And we're going to do it from that point. I remember which one we did. I think it was the middle one. To that point. Now, see it moves, but you see the other one does not, because what we need to do is we need to do from there here. Okay. You can see they move together. Now let's bring back everything else. So here we have our drawer, and if we move it, you can see it all slides out both sides, fully extension. So that's how you create the motion joints, and how you would do it with a part that you're going to bring in from, say, McMaster-Carr. A lot of times those are just not set up correctly to be done. Some other things just to point out, we can also just animate these by animating the joint by just looking at the joint, just going to the joint in the browser and animating the joint. You can do also animate joint relationships, will show it relatively moving, but what you'll see when that happens is it'll move some related joints but not move them back, and then just continue to animate part of that joint. And let's do it on the bottom one. You know, it's pretty much going to show us the same thing. So you don't get a full motion view of it, and the only one way to do it is obviously you can just drag it and you can see how it's moving. But what you really want to do at this point, if you want to see the whole thing moving together, is you want to go under Assemble, and you're going to do Motion Study. And basically with Motion Study, you're going to basically say, what do I want what to do? And the fact that these are all jointed together, we don't need to move every joint that we've created. We only need to move 2 of them, because if we move any one of those, the whole thing is gonna move. So the 2 joints we're going to look at is, so first let's look at this slider joint. We know that that's going to be moving only a total of 9 inches in its length, and the slider 2 is also only going to move 9 inches in its length. But when you pull the drawer out, slider 2 is probably going to move first. So let's just pick slider 2. And so here you get, at a duration of 100, you right now it's not doing anything. It's at 0.25. It's not doing anything because that's what our minimum was set to. But we can go in and let's say at 50, we can say we want to move it 9 inches, and it's going to pop out 9 inches. And we know that's where it stops. So here we have slider 2 at 9 inches. Now we want to add slider 1. And at slider 1 at 100, and that's at the end of us pulling out, is going to go to 9 inches. With this, now that we have this, we can animate this. You can see how it just animated it out. Just coming in and out. I can loop it to go back and forth like we'd expect it to. And here you can see that everything is moving together. All the slides are moving together, and we can just do a continuous loop, which is just going to keep starting it from the front. You can speed it up, slow it down, all those things. So that's the motion study. Trying to capture this as a video, don't know how to do that. I believe you'd have to do that through actually doing an animation through here. And you might be able to do an animation based on a motion study in there. I haven't played around with that yet, but anyway, that's how you get the full view of it. Now under here, I've messed around. There are different motion studies. So once you create that motion study, it does save it. Open that back up, apparently, somehow. Modify. Let's go to Assemble, Motion Study, Edit. So you click on Edit Motion Study and you can play it again. So anyway, that's how you create motions with imported components and doing a motion study to make the whole thing move. So anyway, I hope you enjoyed this video, and please subscribe and leave a like, or any questions or comments, or like, I want to learn from you guys too. Anybody who knows of a little trick in this, certainly share that with the community. And anyway, enjoy working in Fusion, and we'll see you later.